I want to just take a look at two problems that we did back in 14.7. In both problems, we were given a function, different function for each one, but a function of two variables, and then some region D that happened to be closed and bounded. So we knew from the extreme value theorem that an absolute max and an absolute min had to exist, and we knew to check critical points and the boundary. Okay, well, back in 14.7, we checked the boundary by parametrizing the boundary. And now in 14.8, we've learned that sometimes we've got an alternate method. If the boundary can be described as a level curve, we can use Lagrange multipliers. So I just want to compare these two examples. In video 10, we were working with this function, and this was our region D. It was the region between the parabola y equals x squared and the line y equals 9, above the parabola, below the line. Okay. This is not a good candidate for Lagrange multipliers. Now, I could certainly view the parabola as being a level curve for the function y minus x squared, because that would mean y minus x squared was equal to 0. So I could view that as a g of xy. Okay. But I have a second part of the boundary. Now, that of course means y equals 9, and I could view y as being a function of x and y, where x just doesn't happen to show up. So I can view the parabola and the line as being level curves of a function of two variables. But I'm not working with the entire level curve. I'm working with part of the level curve. I'm only working with the portion of the parabola that's below here. So it will be the case that if I have a max or a min that occurs somewhere on the parabola other than at those endpoints, Lagrange multipliers would allow me to find that point. And of course, if I found a solution to my system of equations for Lagrange multipliers and it was on part of the parabola above y equals 9, I would just not include that point. But I would still have to check these endpoints, because it's entirely possible that if I were to include the entire parabola, let's say my function f is increasing as I move along the parabola. Well, if that's the case, then this wouldn't be a max for the entire parabola, but it might be a max on just that portion of the parabola. So if I'm working with part of a level curve rather than the entire level curve, I don't recommend using Lagrange multipliers, because you would have to use Lagrange multipliers and check the endpoints. And I would have to use Lagrange multipliers twice, once for, in this case, once for the parabola and once for the line. And Lagrange multipliers is kind of time consuming. I think it's faster when you're dealing with portions of a curve to simply parametrize that portion of the curve. Okay. In video 11, we worked with this problem. Our function was x times y, that's continuous, and we were working on the solid disk. Okay. So we parametrized the unit circle, but that boundary curve then was just x squared plus y squared equals 1. And I was dealing with that entire boundary curve. Here, I could use Lagrange multipliers on the boundary, or I could parametrize the boundary, and I think either one works equally well. So, be aware that I could, on an exam, give you a question like this, and just say, find the location and value of the max and the min. Okay. In that case, you would have to check critical points and boundary points, but you could choose which method to use on the boundary. You could either parametrize it, or you could use Lagrange multipliers. Now, I might also give you this problem, but specify. I might say, work with the boundary by parametrizing it. Or I might say, use Lagrange multipliers on the boundary. So, for example, the first example that we did in this section was a problem that was on a handout from 14.7 where I parameterized the boundary, but in this section we did it by using Lagrange multipliers, and there I said in the directions, use Lagrange multipliers on the boundary. So I might specify or I might leave it up to you to choose. If I leave it up to you to choose, you want to recognize that if you're not working with the entire level curve, y minus x squared equals 0 would be the entire parabola, then using Lagrange multipliers is acceptable, but you still have to check the endpoints. And in that case, I think using Lagrange multipliers is more work than it's worth. I think parametrizing is a lot easier if your boundary curve, particularly if your boundary curves, if there's more than one, are just sections of a level curve. I think it's easier to parametrize those sections. So just some things to keep in mind as you're sort of strategizing about finding maxes and mins for functions of 2 variables. For functions of 3 variables, if we're finding constrained maxes and mins, Lagrange multipliers is the only method that we've learned that works on the boundary. You just need to remember that if the boundary is your entire region, then you're using just Lagrange multipliers. But if your region is described by some sort of an inequality, you have to still check critical points and boundary points, and then you're just using Lagrange multipliers for the boundary.